Static VLANs trunking in VTP, topology, layer 2 switch, add interfaces. I need 6. Okay, 11 to 11, 12 to 12. I will use 1 1 1 1 1 2 1 2 1 1 1 1 1 2 1 2. 9 10 9 10. I will use 0 3 1 0 0 3 1 0 7 8 7 8. We'll use 0 1 and 0 2. Okay, gigabit 1 3 not in use. Prepare for the lab. Use the reset TCL script you created in lab 1 to set your switches up for this lab. Then load the file base.cfg into the running config with the command copy flash base cfg to running config. Okay, this is the example for DLS1. If you want, run the reset.tcl script previously created using the TCL shell and copy the base.cfg to the running config. Okay, but I prefer to use the notepad. For example, for layer 3 switch, this is the script and these are the commands. Okay. Okay, and run this script or run these commands on VIRL is not necessary because the switches are erased. Okay, the switches are cleared. If you are in a real lab, use these commands or use this script. Okay, also for layer 2 switches. Okay, but for basic settings, use the script. Okay, but for basic settings, use this script on TCL shell or use these commands. The domain lookup, the interface range to shut down. Okay, shut down all interfaces. Okay, verify the range from 01 to 13. Okay, from 01 to 13, from 01 to 03, and from 10 to 13. shutdown, exit, VTP mode transparent, login synchronous online console, and no exit timeout. And finally, the host name. Yes. Okay. All devices in green. Basic parameters. IP addresses on management VLAN according to the diagram. Example for DLS1 on VLAN 99, set the IP address and subnet mask and no shutdown. Okay. According this topology, okay, DLS1 console. Okay, DLS1 enter. Enable configure terminal. Copy and paste the basic settings. Okay. But you can verify the show running configuration to show running config. The gigabit interfaces. The interfaces on this switch gigabit 00 to gigabit 03 and gigabit 10 to gigabit 13. Okay, and basic settings, the range is gigabit 00 to 03 and gigabit 10 to 13. Okay. Global configuration mode, copy and paste the basic settings. Hostname DLS1. And set the on VLAN 99, interface VLAN 99, the IP address 101, 102, 103, 104. No shutdown. Same process on DLS2. Enter. Enable, configure terminal, paste the basic settings, hostname, DLS2, interface VLAN 99, IP address. Shutdown. ALS1, enter. Enable, configure terminal, basic settings, hostname ALS1, interface VLAN 99, IP address 103. No shutdown. ALS2, enter. Enable, configure terminal, basic settings, hostname ALS2, Interface VLAN 99, IP address 104, subnet mask 24. Now shut down. Okay, you can set the passwords, but for now it's not necessary. Configure VTP version 2 VLANs and trunking. A VTP domain, also called VLAN management domain, consists of trunked switches that are under the same administrative responsibility sharing the same VTP domain name. A switch can be in only one VTP domain, and a VLAN database contents in domain are globally synchronized. VLAN information is not propagated until a domain name is specified and trunks are set up between the devices. There are three versions of VTP available. Version 1 and 2 are able to support normal range VLANs only, while version 3 can support normal and extended range VLANs, as well as the synchronization of other databases. Support for version 3 on the Catalyst platforms used in this lab was added in iOS version 12.2. Older iOS versions do not generally support VTP version 3. Switches operate in one of four VTP modes: server, client, transparent, off. Okay, this topology, VTP version 2 between DLS1 and ALS1, and VTP version 3 for the remaining switches. Okay, design, text, VTP version 2, and VTP version 3. Okay, VTP version 2 between DLS1 and ALS1, and VTP version 3 and all other connections. Okay, verify VTP status, DLS1, and show VTP status. Okay, version running 1, no domain name, mode transparent, version capable from 1 to 3. As you should recall from CCNA, the configuration revision number is compared amongst VTP version 1 or VTP version 2 switches, and the VLAN database from switch with the highest version number is adopted by all other switches in the VLAN management domain. Every time VLAN information is modified and saved in the VLAN database, VLAN the revision number is increased by 1 when the user exits from VLAN configuration mode. In VTP version 3, revision numbers are still used, but they no longer determine the switch whose database is going to apply to the entire domain. Instead, a single designated switch is a VTP domain called the primary server is allowed to assert its database in the entire VTP domain, even if its revision number is lower. Other switches that are not primary servers are not allowed to assert their databases, even if their revision numbers are higher. Multiple switches in the VTP domain can be in VTP server mode. In version 1 and 2, any of these server switches can be used to manage all other switches in the VTP domain. In VTP version 3, a single primary server for a particular VTP domain is designated to control where changes originate from in the switched network. This enables careful management and protection of the VLAN database. Configure VTP on DLS1. Okay, configure the domain, the version, the mode, and set the password. Okay, configure terminal, VTP, domain, switch lab, VTP version 2, VTP mode server, VTP password, Cisco 123. Now verify and show VTP status. Okay, version 2 domain, mode server. Okay, also you can use show VTP password. Okay, ready. Now configure VLANs on DLS1. There are two ways to create VLANs, either directly via VLAN command or assigning an interface to a non-existent VLAN. Okay, create VLAN 99 for management, 999 for parking lot for unused access ports. Suspend this VLAN to prevent ports in the VLAN from ever communicating with each other. The VLANs required for network operations 100, 110, 120. Suspending a VLAN deserves a special mention. Each VLAN has an operational state associated with it. It can be either active, the default state, or suspended. A suspended VLAN exists, but it does not operate. Access ports assigned to a suspended VLAN drop all frames and are unable to communicate, similar to ports put in a non-existent VLAN. Putting a suspended VLAN back into the active state reinstates normal communication on ports on that VLAN. To globally suspend a VLAN, use the state suspend command in the VLAN configuration mode. This state is propagated by VTP to all other switches in the VTP domain if VTP is in use. To locally shut down a VLAN, use the shutdown command in the VLAN configuration mode. This setting is not propagated through VTP. Okay, now configure all these VLANs on DLS1. Configure terminal, VLAN 99, name, management, VLAN 100, name, servers, VLAN 110, name, guest, 120, name, office, VLAN 999, name, parking lot. And suspend this VLAN. State suspend. VLAN 666, name, native, do not use. And exit to apply changes. The VLANs will not appear in the VLAN database until the exit command is issued. Okay, verify, show VTP status, and show VTP status. You will see that the all important configuration revision number has increased based on these changes to the VLAN database. Okay, revision configuration revision 6, because you created 6 VLANs, 1, 2, 3, 4, 5, 6 VLANs. You can include this keyword to show only this line. Use the pipe, use the keyword include configuration revision. Okay, you will see only the configuration revision number. Trunking on DLS1. Okay, for example, VTP will only propagate information over trunks. Cisco switches support dynamic trunking protocol DTP, which allows automatic negotiation trunks. Verify the interface 7 on ALS2 or ALS1, any of these. Okay, for example, on LAS1, for example, gigabit 01 on ALS1, and show interface gigabit 01 on switch port. Okay, you will see the name, the administrative mode, dynamic auto. Okay, administrative trunking encapsulation, negotiation of trunking on switches that are interconnected and have DTP enabled can form a trunk automatically if either end is in the dynamic desirable mode or static trunk mode on the condition that either both switches uses the same VTP domain name, or at least one of the switches does not yet have a VTP domain name configured. The dynamic auto mode on both ends will prevent the trunk from automatically forming. However, this is not really a valid safeguard against unintentional trunk connections, as the port can become a trunk if the other side changes to dynamic desirable or static trunk mode. As a best practice, you should configure each interface into either access or trunk mode and use the switchport non-negotiate interface configuration command to disable the propagation of DTP messages. Never leave ports to operate in the dynamic mode. Okay, configure the appropriate interfaces on DLS1 to be trunks. Okay, because DLS1 is a layer 3 switch 3560, you must first specify the encapsulation protocol for the interface. Catalyst 3560 switches supports ISL, inter-switch link, and 802.1q encapsulations for trunk interfaces. Okay, in the topology, all the trunks are AO2.1q trunks. Okay, change the native VLAN from the default of VLAN 1 to VLAN 666. Apply the switch port, no negotiate, and no shutdown, because the configurations of lab 1 has all interfaces shut down. Okay, apply all these commands on DLS1. Okay, go to DLS1. Okay, DLS1. And configure terminal. Apply the range from 01 to 03, 01 to 03, and from 10 to 13. No, and from 10 to 12. 10 to 12. 13 is not in use. Okay. Enter. Enter. Switch port trunk encapsulation .1q. Switch port trunk native VLAN 666. Switch port mode trunk. Switch port no negotiate. And now shutdown. Okay, on DLS1, by default, all VLANs are allowed on all trunks. You can explicitly control which VLANs are allowed on a trunk by using the switch port trunk allowed VLAN and VLAN ID command on the interface and each end of the trunk. There are several approaches to deciding what VLANs to allow or disallow to cross the trunk. Common practice is disallow VLAN 1 in the parking lot VLAN. Disallowing the parking lot VLAN from all trunks is not really necessary since the VLAN has been suspended. Disallowing the VLAN can serve as an additional protection against inadvertent reactivation of this VLAN. Disallowing VLAN 1, also referred to as VLAN 1 minimization, excludes VLAN 1 from the trunk but does not restrict layer 2 management traffic such as CDP, LLDP, VTP, STP, etc. from passing. Since only these two VLANs are being disallowed, the exact version of the command can be used. Okay, remember, I am still in the range, okay, and in this range of interfaces, okay, switch port, trunk, allowed VLAN, and mark question to view the options. You can add all, except, none, or remove. I will use except one and parking lot 999. For example, on DLS1, verify and gigabit 01. Okay, and show interface gigabit 01 switch port. Space negotiation trunking off. Operational mode trunk, administrative mode trunk, encapsulation .1q, operational trunking .1q, trunking native mode VLAN 666, okay, this name, and trunking VLANs enable this range, except 1 and 999. Configure VTP and trunking on ALS1. Okay, configure on mode client the range of interfaces using VLAN 666 for native VLAN 666, trunk non-negotiate, all allowed except 1 and 999 not shut down. Okay, on ALS1, go to this switch ALS1, configure terminal. Okay, the range from 01 to 03. Okay, but first of all, VTP mode client. Okay, now the range interface range gigabit 01 to 03 and gigabit 10 to 12. 13 is not in use. Switch port trunk native VLAN 666. Switch port mode trunk. Okay, set the encapsulation. Okay, switch port trunk encapsulation .1q. Switch port mode trunk. Switch port no negotiate. Switch port trunk allowed VLAN except 1 and 999. Now shut down. Okay, and verify trunking, show interfaces trunk. Okay, mode on encapsulation .1q native VLAN 666. Show VTP status on LAS1. Okay, version 1 operational mode client revision number 0. No domain name. Okay, set the domain, the password for VTP. Configure terminal on ALS1, VTP, domain, switch lab, case sensitive, VTP password, Cisco 123. Okay, and verify, show VTP status. Okay, domain name, switch lab, mode client. Okay, show VTP status again. Show VLAN brief. Okay, may take a while. Show VTP status again. Show VLAN brief. Show VTP password. Okay, may take a while. Okay, now is synchronizing with the VTP server. Okay, the VTP version running version 2. Okay, the server determines the version and the revision number now is 6. Okay, the VLANs from the server, domain name. Okay, show VLAN brief. Okay, finally you have the VLANs from the server. Okay, parking lot is suspended. Okay, very good. Show interfaces trunk on ALS1. Look at VLANs Yawata trunk, all except 1 and 999. Because ALS1 is a client on VTP, local changes to the VLAN database cannot be made. Configure terminal VLAN 199. VTP VLAN configuration not allowed when the device is in client mode. Park unused interfaces. On DLS1 and ALS1, place all interfaces that will not be used into the parking lot VLAN and shut them down. For this lab, the interfaces being used on all switches are 7 to 12. Okay, in my case, on DLS1, 1.3 is not in use. Also, in ALS1, 1.3 is not in use. Okay, go to DLS1, configure terminal, interface, gigabit 1.3. Switch port mode access, switch port no negotiate, switch port access VLAN 999, the parking lot, and shut down the interface or interfaces. ALS1, the same process, interface gigabit 1.3, switch port mode access, switch port no negotiate, switch port access VLAN 999, shut down. Next. Configure VTP version 3 VLANs and trunking. First, the concept of primary server was added. VTP versions 1 and 2. All VTP server switches are equal. Any one of them may add, remove, rename VLANs, and change their state. In VTP version 3, only the primary server can do this. There can be at most one primary server present in a VTP domain. The role of primary server is a runtime state. It is not a part of the configuration. Rather, this state is requested in privileged exit mode, relinquished whenever another switch attempts to become the primary server or when the switch is reloaded. Second, VTP version 3 has the ability to hide the VTP password. On a VTP version 1 or 2, switch issuing the command show VTP password will show the password to you in plain text. VTP version 3 allows to specify that the password be hidden in the output. Third, VTP version 3 can propagate information about extended range VLANs. VLANs numbered between 1006 and 4094. To support these VLANs with VTP version 2, all switches had to be in transparent mode, and the VLANs had to be configured manually on a switch-by-switch basis. Fourth, VTP version 3 only supports running for normal range VLANs. Fifth, VTP version 3 supports propagating private VLAN information. As with extended range VLANs, the lack of VLAN support in VTP version 2 required all switches to be transparent modes and manual configuration at each switch. VTP version 3 added support for opaque databases VTP version 3 can transport more than just the VLAN database between switches. VTP version 3 is backwards compatible with VTP version 2. At the boundary of the two protocols, a VTP version 3 switch will send out both version 3 and version 2 compatible messages. Version 2 messages received by a version 3 switch are discarded. Okay, configure VTP on DLS1, DLS2, and ALS2. DLS1, DLS2, and LAS2. VTP version 3 cannot be configured unless a VTP domain name has been set. So for this step, setting the domain name is not needed on DLS1. Configure VTP version 3 using the following parameters. VTP domain switch lab only on DLS2 and ALS2 because DLS1 already configured. Because the domain already configured on DLS1, VTP version 3 on DLS1, DLS2, and ALS2. Mode server on DLS2 and ALS2 already configured the mode server on DLS1 and VTP password Cisco 123 only on DLS2 and ALS2. Okay. On DLS1, enter configure terminal VTP version 3. Okay, on DLS1, the mode server already configured and the domain already configured. Okay, show VTP status. Okay, version 3, server, domain switch lab. Okay, and also the password already configured. Okay, on DLS2, okay, DLS2, enter show VTP status. Okay, transparent, no domain, version 1. Okay, configure terminal VTP domain switch lab VTP version 3 VTP mode server VTP password Cisco 123. Okay, the same process on LAS2. Configure terminal VTP domain switch lab VTP version 3 VTP mode server VTP password Cisco 123. Configure trunking on DLS2 and ALS2. Okay, the interface range and native VLAN encapsulation, mode trunk, no negotiate, trunk logget, no shutdown. Okay, look at the range on DLS2. Okay, DLS2 interface range gigabit 01 to 03, comma, and gigabit 10 to 12. All trunking interfaces. Okay. Switch port trunk native VLAN 666. Switch port trunk encapsulation.1q. switch port mode trunk, switch port no negotiate, switch port trunk allowed, VLAN except one and parking lot 999, not shut down and exit. ALS2 interface range gigabit 0123 gigabit 1022 switch port trunk native VLAN 666 trunk encapsulation .1q switch port mode trunk no negotiate trunk layout VLAN except 1999 not shut down exit. Okay, verify and show interfaces trunk. Okay, native VLAN 666 trunking .1q. Okay, VLANs allowed all except 1 and 999. Show VTP status. Okay, version 3, domain, server. And look at the configuration revision number is 0. Verify on DLS2 and show VTP, show interfaces trunk. Okay, native encapsulation all except 1 and 999. Show VTP status. Version 3, domain, revision number 0. Notice that the configuration revision number is 0 and the number of local VLANs is the default of 5. There has been no update because DLS1's configuration revision number was reset to 0 when the VTP version has changed. So at this point, DLS2 and ALS2 will not learn about the configured VLANs because as far as they are connected, they have the same database as DLS1. Verify the revision number on DLS1. Show VTP status. Okay, reset to 0. Okay. If we attempt to add VLANs on DLS1 or any other VTP version 3 switches, our attempt will not work and will be told that we cannot add VLANs. Okay, configure terminal VLAN 111. VTP VLAN configuration not allowed when the device is not the primary server. Okay, now configure the primary VTP server. In VTP version 3 domain, only the primary server can make changes to the VLAN database. Becoming the primary server requires the VTP primary privilege exit command to be executed. When you issue that command, the switch checks to see if there is another switch acting as primary server already, and asks you to confirm that you want to continue. Okay, in the output of DLS2 above, notice that the primary ID field is equal to 0. That field will display the base MAC address of the primary server once the device is promoted into that role. Okay, DLS2, the primary server ID is 0. Will be replaced later with the MAC address of the primary server. The primary server can be configured independently for each feature supported VLAN or MST. If no feature is specified, the VLAN feature is assumed. There is a force option which causes the switch not to check for conflicts in the identity of the primary server. Okay, VTP primary and mark question on DLS1 exit privilege exit mode VTP primary and mark question. You can set the VLAN feature of MST or use the force. Okay, use VLAN and enter. The system is becoming primary server for feature VLAN. No conflicting VTP3 devices found. Do you want to continue? Confirm, enter. Okay, this base MAC address for DLS1 has become the primary server. Okay, on DLS2 verify, show VTP status. Now the primary ID is the base MAC address of DLS1. Configuration revision 1, existing VLANs 11. Okay. Before the existing VLANs were 5, configuration revision 0, and primary ID 0. Okay, space, repeat the command, show VTP status. Now the primary ID is DLS1, configuration revision 1, 11 existing VLANs. The promotion of DLS1 to primary increments its configuration revision number to 1. So the VLANs that were previously created on DLS1 are propagated to DLS2 and ALS2 automatically. Okay, DLS2, for example, show VLAN brief. Okay, the 11 VLANs. (999) suspended. Park conjugate interfaces. Okay, on DLS2, configure terminal. Gigabit 1.3 is not in use. Interface gigabit 1.3. Switch port mode access. Switch port non-negotiate. Switch port access VLAN 999 and shut down the interface. The same process on ALS2. Configure terminal interface gigabit 1.3 switch port mode access switch port non-negotiate switch port access VLAN 999. shut down. Okay, verify VLAN management capability. TLS1 is able to create VLANs, included extended range VLANs. Note that because ALS1 is running VTP version 2 and its revision number is 6, it will ignore any of the VTP version 2 messages sent to it because they have a lower revision number. When a VTP message with an equal revision number with different MD5 checksum is received, ALS1 will report an error. Here we added 7 VLANs and then removed 6 of them to push the revision number on DLS1 to 9. Okay, for example, on ALS1, show VTP status. Okay, version 2, revision number 6, but DLS1 show VTP status, revision 1, version 3. Okay, on DLS1, configure terminal VLAN 510, name test 510, exit VLAN 511, name 511, exit VLAN 512, name 512, exit VLAN 530, name 530, okay, VLAN 1500, name test extend, and remove no VLAN from 510 to 514. Enter. Okay, and verify on DLS1, show VLAN brief. Okay, 515 active, the extended 1500 active. Okay, 2 additional VLANs. Show VTP status. Okay, revision number 9. Okay, verify ALS1. Show VTP status. Revision number 9 and version 2. Show VLAN brief. Okay, 515 active, but no extended VLAN because VTP version 2 does not propagate extended VLANs. Okay, no 1500 VLAN. But verify on DLS2, show VLAN brief, and now 515 and 1500 is propagated also on LAS2 and show VLAN brief. Okay, VLAN 515 and extended VLAN. Change the VLAN status to deactivate ports. The default status of VLAN 1 and user-created VLANs is active, A VLAN can be made locally inactive by entering the global configuration command shutdown VLAN and the VLAN ID, where VLAN ID is the number of the VLAN to be shut down. The VLAN can be shut down by issuing the shutdown command while in VLAN configuration mode and then exiting. Okay, but these options are equivalent. However, only the shutdown VLAN command works while in VTP client mode. Shut down the guest VLAN 110 on ALS1, wait a few moments, exit the configuration mode, and then issue the show VLAN brief command. The status should change to active shutdown. Local shutdown, LShut. Okay, on ALS1, shutdown VLAN 110. And show VLAN brief. Okay, active locally shutdown. Okay, reactivate VLAN 110. Okay, configure terminal. No, shutdown VLAN 110 and show VLAN brief. Okay, active. You can put a VLAN into suspending status by using the state suspend command while in VLAN configuration mode on a VTP version 2 server switch or on the VTP version 3 primary server switch. In a mixed VTP version network, the suspension only works network-wide if it originates from the VTP version 3 primary server. Suspending a VLAN causes all ports in that VLAN through the VTP domain to stop transferring data. Okay, suspend the VLAN 110. Okay, on DLS1, the primary server, configure terminal, VLAN 110, state suspend. Okay, on DLS1, show VLAN brief, suspended, DLS2, suspended, ALS1, suspended, ALS2, suspended. Reactivate state active. Configure terminal, VLAN 110, state active. And active ALS1, active ALS2, active DLS2, active. Okay, and save your configurations. The equipment should be in the correct end state from this lab for lab 3-2 Ether channel.